So there's this new paper from DeepSeek, and let me tell you, its name is hiding something huge. On the surface, it's about one thing, but what's really going on? Well, it's a game changer.
You've heard it a million times, right? A picture is worth 1,000 words. We always think of it as, a metaphor for how much an image can express. But what if it wasn't a metaphor? What if you could take it literally? Because that's exactly what the researchers at DeepSeek did. They figured out a way to take 1,000 words, bake them right into an image, and then have an AI read it back with near perfect accuracy. Now that is the revolution we're really talking about today. Okay, so the paper is officially called DeepSeek OCR, optical character recognition. And yeah, it's fantastic at reading text from images. But honestly, calling this just an OCR paper, it's like calling a spaceship a car. The real story is so much bigger than that. The real innovation, the true heart of this paper, is a concept they call context optimal compression, and it's a wild idea. They're literally using vision, the way an AI sees, as a super powerful compression tool for text. This isn't just a small step forward, it's a completely new way of looking at the problem. So you might be asking, why is this such a big deal? Well, it tackles one of the biggest headaches in AI right now, the long context problem. Basically, how do we get these massive AI models to remember and process huge amounts of information without getting lost or overwhelmed? Think about it like this. Right now, with today's LLMs, we're struggling to push past 1,000,000 tokens of context. And that's because pretty much every word you feed it costs 1 token. It adds up fast. The dream, though, the goal, is to have an AI that can handle tens of millions of words. Like, it could read an entire series of books or remember every conversation you've ever had with it all at once. And this is where DeepSeek's idea is so brilliant, so radical. They thought, okay, instead of just cramming more and more text tokens into the AI's memory, what if we could hide them? Hide them inside something way more efficient, vision tokens. And just look at how efficient this is. The model can take 1,000 text tokens, that big chunk of data, and squeeze them down into just 100 vision tokens. That's a 10-to-1 compression. It's kind of nuts. But here's the real kicker. It does that insane 10x compression and can still bring back the original text with 97% accuracy. So you're getting this incredible efficiency, but you're barely losing any of the information. It's pretty much the best of both worlds. And believe it or not, it gets even crazier. If you really push it all the way to 20x compression, we're talking just 50 little vision tokens for 1,000 words. It still holds on to about 60% accuracy. That just goes to show you how powerful and flexible this whole approach is. All right, so how on earth are they pulling this off? The secret sauce is a new piece of tech they built called the Deep Encoder. It's this really clever 2-stage system they designed just for this kind of high-detail compression job. So here's how it works. It's a 2-step dance. First, a smart system scans the image. Think of it like a detective, using a magnifying glass to spot every single important detail. Then, in the second step, another model comes in and connects all those dots. It doesn't just see a bunch of details, it understands how they all fit together to create a super efficient summary. It's not just seeing the letters, it's getting the whole picture. Let's put this into a real-world context. To process a document, a normal text-based model might burn through, say, 6,000 tokens. But with this deep encoder, you can represent that exact same document with less than 800 vision tokens. I mean, that is a huge, huge drop in the amount of work the computer has to do. Okay, let's step back for a second and look at the big picture. What does a breakthrough like this actually mean for the future of AI? Now, to be fair, they proved this works on OCR tasks. But what they've really done here is so much more important. They've basically created a blueprint, a proof of concept, for a totally new kind of AI memory. And the possibilities this opens up, they're just mind-boggling. We're talking about AI with context windows that feel like 10 or even 20 million tokens. Imagine being able to feed an AI your entire chat history, just as a few compact images. This could completely change in-context learning and fundamentally reshape how AI systems remember things. Which leaves us with this one kind of wild question. Could the future of AI memory look less like a giant library of text and more like a photo album? Based on this research, that future might be a lot closer than we think.